Part 2 of the Unit 5 review is here. Remember, this is inside your student activity book. So x plus 49 is equal to 65, and I can use any method to solve this, but I must check my answer. So I'm going to use the inverse operations. I'm going to subtract 49 from each side. X will equal the difference of 65 and 49. So x is equal to, carry from the 5, make it 6. X is equal to 16. I plug it in. Now, 16 plus 49 should be equal to 65 if I did this correctly. And we'll see. So 16 plus 49, I like to put my numbers under. That equals 15, carry the 1, equals 65. So my answer is truthful. It is x is equal to 16. Now this one is multiplication. So I will have to divide to do the inverse operation to get it by itself. So when I divide x by 15, that cancels it out and leaves me the x by itself. 15 will go into 135 how many times? Well, I know it's not 10, so it's 9. So I multiply that and I get 135. So x is equal to 9. Now I need to try this out before I do anything. So in order to try this out, I will multiply 15 by 9 and find the product, hopefully, of 135. Let's see, 14, 13, 135 equals 135. Totally works. Good job, self. Now it says in 21 and 22, write an equation to represent the problem. Then I'm going to use that equation to solve it. So 12 of the students in the science club went on a trip to the planetarium. If this is 3/4 of the students in the club, what is the total number? So 12 is equal to 3/4 multiplied by C. I'm just going to call it C for the class number. So 3/4 times C, because it's 3/4 of the club multiplied by the total numbers, gives me 12. So I'm actually going to be dividing 12 by 3/4 using the inverse operations to cancel the 3/4 out on the other side. So when I divide, I flip a change and multiply. 12 over 1 is like multiplying by 4 over 3. I go straight across. 48 over 3. 3 goes into 48. 3 goes into 4 once with 18. 3 goes into 18 6 times. So my total class equals 16. If I was finding 3/4 of 16, that's what I would do. 3/4 multiplied by 16, and I would get 12. After Janelle deposited, so she added money. This must be a good problem. If she's adding $72.50 into her bank account, her balance was $323. What was her balance before? So that's what I don't know. And I'm going to just use B for balance. But I know her balance plus $72.50 gave her $323. So using inverse operations, I will subtract $72.50 from each side, and hopefully I'll be able to find B. When we do this, or at least when I write equations, I will go back multiple times through the problem just to make sure it makes sense. So I subtract $72.50 and subtract $72.50. It leaves the B by itself, but it will also give me the answer on the other side. So I borrow from the 3, make it a 2, and I make that a 10, and you'll see me try, oh yeah, I gotta borrow to the 0. 0 minus 0 is nothing, self. You see me catch myself. That actually is still a 10, and I get 50 cents on this side. 2 minus 2 is 0. Now I need to borrow, make that a 2, 12. 12 minus 7 is 5. Bring down my 2, $250.50 is what she had before. So she had $250.50 and she deposited $72.50. So she had a total balance of $323 after. So Bennett's phone plan charges extra if he talks more than 300 minutes a month. More than 300 minutes. He was charged extra in May. So this says, let M be the number of minutes. I put my M there. Minutes Bennett talks on his phone in May. Write an inequality for the possible values of M. M must be more than. Notice this doesn't say 300 minutes or more. That'd be more than or greater than or equal to. So now I can plot this. I'm going to use hundreds so I don't have to make 300 dashes. That sounds terrible. When you're doing this, you need to use your best mathematician eye for how many spaces you have and what it should equal. So if M is greater than 300, I do an empty circle and I color in my line to show that 400, 500, 600, 700, all of those are greater than 300. Now we're on to page 424. I'm still graphing inequalities. When the temperature is 20 degrees Fahrenheit, or less. Oh, see, that's telling me it's going to be less than or equal to. So you see me try and draw it, then it kind of gets all wrangled, I guess. I'm just going to try again. So when it's 20 degrees Fahrenheit or less, Jen wears a full-length parka. Let T be the temperature. So T, when it's 20 degrees, so it's less than or equal to 20 degrees. So anything below 20 degrees and 20 degrees. So when I'm doing this inequality, I'm not going to go by hundreds again. That's a little too crazy, but I'm going to go by tens. So 0, 10, 20, 30, 40, 50, 60, 70, however many I get to. And this is less than or equal to. So my dot will be filled in at the 20, fill, and it's going to go to the left because it's less than. Telling me 20 is less than or equal to, 10 is less than or equal to, 7 is less than or equal to. Now we're going to fill out our table. So an online sock store charges $3 per pair of socks. Then they charge $1 for a delivery, no matter how many the pair. So that's already filled out. We need to complete it. So one pair is $3 plus $1 for shipping is $4. And this has 2 to 6. Well, that's because it's multiplied by 3. Each pair is $3. So 3 times 3 is 9 plus 1 is $10 for 3 pairs of socks. 4 would be 4 times 3 is 12 plus 1 is $13. I have to include the shipping. 5 times 3 is 15 plus 1 is 16. Now I'm going to plot the values for the pairs bought. That's the X, and the total cost. That's the Y. I have to include my shipping. Like that's just has to happen. And I'm going to write my equation of 3n plus 1. So every time I had the number of socks, I multiply that by 3 because they're each 3 pairs. And I have to add 1 for the shipping. So 1, I go up to 4. For 2, I go up to 7 because that's the total cost including shipping. For 3, I go up to 10. For 4, I go up to 13. And for 5, I go up to 16. Now, remember to always check your answer as if you can use your table with the equation. Does it work out? Is it a good equation? That'd be a good way to check it. And like it said, use the dashed lines. I'm going to pull mine all the way to 0. You could put in your rate triangle if you so choose, your voice and choice. I'm also going to write my coordinates on here. So 5, 16, 4, 13, 3, 10, 2, 7, and 1, 4. And if you notice, the X being like 5, that's the total number of pairs of socks. The Y being 16, that's the total cost. It's kind of crazy, right? So explain how the cost of each pair of socks is represented in the graph and in the equation. When I do things like this, I always double check my work, but I look at the graph and make sure that it makes sense. Like I didn't just throw some dots on there. So in the graph, the height, again, that's the Y. The height is going to tell me kind of unit rate. And with the unit rate triangle, I am also able to double check my work because we know these are like a constant thing. So it's not like I need to just, guess 317. So in the graph, it is the height of a unit rate triangle, the very top of it. In the equation, it is the coefficient, so 3. So each pair of socks is that like that letter and that number, right? So each pair is $3. That 3n plus 1 makes sense. Explain how the shipping charge is represented in this graph and the equation. Now, I think on the quiz, there were some people that got confused whether to include the shipping charge or not. You must include it. It is asking for the total cost. In the equation, it's that plus 1. No matter what, we're adding 1, we're adding 1, we're adding 1 because of the shipping. So in the graph, it is where the line starts on the vertical axis. And then in the equation, it's that 1. That shipping charge does not go away no matter how many socks you buy. So I could buy 100 pairs of socks and they're each $3. So that's $300, but I have $1 for shipping. So it would be 301. And I'm going to write it right here, 3n plus 1. You can totally review these more than once. I do encourage it. And I think you'll do great on the assessment. Give it your all.